You know, we rely on our electronics for just about everything, but what happens when they fail in places where failure, well, it just isn't an option? Today, we're diving into a really groundbreaking idea that tackles this problem head on, circuits that can, believe it or not, actually heal themselves. Think about it. A satellite way out in deep space, a life support system in a hospital, or a critical piece of military hardware out in the field. In these situations, the stakes are incredibly high. Things have to work, period. But there's a huge problem hiding inside all of these advanced systems. See, the electronics at the very heart of these technologies are surprisingly vulnerable, especially when they're pushed to the absolute limit in tough environments. And the cost of that failure, it can be absolutely catastrophic. And when you look at the numbers, wow, they are just staggering. In the brutal environment of space, more than half of all electrical systems eventually give out. For military gear that's being pushed to its breaking point, that failure rate can climb as high as 30%. And we're not talking about small glitches here. These are the kinds of failures that end missions. So what's causing all this? It's a relentless attack from things like wild temperature swings, intense radiation, and just constant physical stress. These forces are always hammering away at the super delicate pathways inside our most important electronics, and eventually something gets. And the crazy part? It doesn't take some massive disaster to cause all this chaos. A single microscopic break in a circuit trace, something you'd never even see. That's all it takes. That one tiny flaw can shut down a multi-million-dollar satellite, put the safety of an autonomous car at risk, or force an entire fleet to be grounded for expensive repairs. This is where we hit a wall. The old way of just repairing or replacing things, it just won't work here. What we really need is a huge shift in thinking. We need electronics that aren't just tough, but are actually resilient. So, what if we change the game entirely? Instead of just trying to build stronger walls, what if a circuit could intelligently react to damage? What if it could feel a problem and in basically an instant fix itself? And that's the big idea behind something called RegenCircuit. It's designed from the ground up to be autonomous and adaptive. So when a pathway gets damaged, the circuit doesn't just die. Nope, it finds the problem, isolates it, and immediately reroutes the electricity through a backup path, getting everything working again almost instantly. Okay, so how on earth does that even work? It sounds like something straight out of a sci-fi movie, right? But the secret is actually really clever, and it all comes down to some incredible material science. The whole trick lies in one special material. The magic ingredient here is a material called vanadium dioxide, or VO2 for short. Just think of it like a tiny smart switch. Normally, it's an insulator. It blocks electricity. But when it gets hot, bam, it goes through this thing called a phase transition and instantly becomes a conductor. This one-of-a-kind property is what powers the whole self-healing process. Okay, let me walk you through how this all happens in like a split second. First, everything's fine. Current is flowing down its normal path. Then, a fault happens, a tiny break in the line. The electricity flow stops dead, and that causes the temperature right at that spot to spike. That heat is the trigger. It flips on the nearby VO2 bridges, turning them from insulators into conductors, which creates a brand new highway for the electricity. Just like that, the circuit's back online with zero human help. Now, there's one more really clever trick that makes this whole thing practical for the real world. Pure vanadium dioxide makes this switch at around 68 degrees Celsius, which can be a little too hot for a lot of electronics. But by mixing in just a tiny bit of tungsten, a process called doping, you can actually tune that transition temperature, bringing it down to a much more useful level. This fine-tuning is what makes the system stable and ready for all kinds of different environments. So you see, this isn't just some neat engineering trick. It's a total game changer for how we think about the lifespan and reliability of our electronics. The benefits here are huge, and they really break down into three main areas. First, you get operational continuity. Critical systems stay up and running even when something breaks. Second, you get way lower maintenance costs because you don't need to do as many difficult or sometimes impossible repairs. And finally, you get less e-waste. By making our hardware last longer, we can seriously cut down on the amount of electronics we throw away. And when you start thinking about where this could be used, well, the list is pretty much endless. We're talking about satellites that can survive radiation hits, military gear that keeps working in the absolute worst conditions, medical implants that are more reliable, and safer electronics for things like self-driving cars and green energy systems. Now, an idea like this is amazing, but it's just an idea until you can prove it works in the real world, right? And that's where a really tough validation plan comes into play. And this isn't just wishful thinking. The plan to prove this out is incredibly thorough. It involves intense thermal cycling to mimic extreme temperature changes, endurance tests to see if it can heal itself thousands of times over, and environmental stress tests that basically recreate the brutal conditions of space or a battlefield. And they've set some really clear, ambitious goals to define what success looks like. They're targeting a repair time of under 5 seconds and the ability to withstand at least 1,000 of these self-healing cycles. This isn't just about surviving one failure. It's about surviving again and again and again, reliably for the entire life of the system. When you put it all together, RegenCircuit isn't just a new part you slap onto a board. It's really a whole new layer of resilience that we can build right into our electronics. It's an adaptive, sustainable, and smart approach built for the real world's toughest challenges. And that really leaves you with a powerful question, doesn't it? For years, we've been obsessed with making our electronics smarter, faster, and smaller. But maybe the next huge leap forward isn't just about being smart. Maybe it's about being resilient. Isn't it time our technology learned not just to think, but to heal itself?